Good morning. My talk is about performance tuning public mail server. The announcement was that we are performance tuning for 4 gigs per second. That's the goal of it, but we are not really there. I want to introduce myself. Been a sysadmin since 1990. That's on my professional life. Before that, I was doing a lot on computers. At that time, the network was ArcNet and the server software was Novell, so we've been involved since that time. Start using Linux since 1995, and since 2012 I'm supporting the ftp.nluug.nl. Currently working at Proxy. I'm in the managed service team, where we do all kinds of support for several clients. One of our clients is Fokker, we have Centrade, and NIBC, it's a banking, doing all kinds of fun stuff. Besides my professional work, I'm doing a lot of analog stuff, doing photography, large format, and my workflow over there is 98% analog. The only digital stuff I use is my light meter, my timer for my enlarger, and the developer. So that's some old school stuff. The history of ftp.nluug.nl. I've read some old news announcements on the site, so it's been there for a long time. It probably was one of the first mirror servers in the Netherlands, probably Europe. It started out at NLnet. That was the first provider of internet in the Netherlands for end customers. It started out in probably 1992 with the Sun 4 670, very old server. Later on they added some other servers, and at that time they had a large modem pool of sideshare modems. The internet speed around that time was about 16 kbps, so it was not very fast. I've seen some usage in December 1992, the whole month. The total download was about 427 megabytes. So at that moment we are doing that in about a minute. So speed has been raised, and also the throughput of the servers. NLNet supported the housing and the internet of the NLUUG server, and the access to the server was with email. You could send an email to the server with requesting a file. FTP was there. Gopher, who knows Gopher? Only a lot of old guys around here. So everybody knows Gopher.
It's called seasoned guys.
Yeah. Also UUCP. The projects that were mirrored were GNU, some facts, FreeBSD, Linux, and X Windows.
X Windows system, please, or X11.
Okay, thanks for clarifying that. Let's see. And then at around 1996, AT Computing was celebrating their 10 years anniversary. They donated a Pentium PC, some disk space, the housing and the maintenance of the server. And that was very successful. In June 1998, the server was housed at NLNet and AT Computing building. They had a 2 megabit internet connection, and it was totally saturated by the ftp.nluug.nl. So the bandwidth was throttled. So the customers of NLNet weren't affected by the popularity of the NLUUG server. Later on, the housing was at J.H.A. and SurfNet is supporting us with the housing and the internet connection. And around 2000 there was a 100 megabit connection, and later on it was upgraded to 1 gig. The former hardware, it consisted of 2 servers with round-robin DNS above it. The storage was SATA disk attached to the system's SCSI interface. It was designed in such a way that if one machine was failing, the disk were manually stuck onto the other server, and then the service could be restored. There was an NFS and GFS connection between the 2 servers, so that every server had an internet connection and could access the files. We upgraded around 2 years ago to a single server. I've put some disks in it, RAID controller, 4 times a 1 gig interface connected to SurfNet, and since 2 years we are running on that server, and it's very successful. Here are some bandwidth graphs. The top graph is saying the former 2 servers. They did around average 160 megabytes per second, and that's around 2 terabytes a day. At the moment we are running on 1 server, and on that server we have a peak, and these are daily average of 800 megabit. Average is 340, around 400 megabit, and at the moment we serve around 4 terabytes of data per day.
So what happened in July?
I don't know, probably some outage, or that MRTG wasn't running correctly. But we never had such a long downtime. I figured out, okay, we are using around 17 terabytes of storage, and I did some finding on the file systems, and we're doing about 40 million files, where 12 million files are smaller than 1 megabyte. A lot of directories and a lot of hard and soft links. And it surprised me that the figures weren't bigger than this, because we are mirroring a lot of files, a lot of distribution, and yeah, around 30 million files. I thought it was more than that, but you can make it better than this. Lately there was some statistics sent around about maximum throughput in a month. And what surprises me, that in April 2008 around 100 terabytes was being served. So I looked in the statistics, and the Knoppix distribution was the largest hit in 2008. There are some other peaks. November 2013, OpenSUSE, a new release was being released, and at that time we hit the border of 100 terabytes in a month. At the moment we are doing about 128 terabytes a month, and the most bytes of terabytes is for the Knoppix distribution and Blender. And I'm going to talk about something, the tools we are using. When I monitor the performance, ATOP tool is the program most of the times I'm using that. it's an ASCII performance monitoring. It monitors system activity for CPU, memory, disk and network. I installed a kernel module that's called NetAtop, and it shows your network activity per process or per thread. So if you look at this picture, it was a snapshot from yesterday evening. We are doing 561 megabit per second, and it's all HTTP traffic. With the NetAtop kernel plugin, you can see that on this picture we have HTTP sessions which doing 58 megabit. So it's very useful to dig in which process is consuming your bandwidth. And there are a lot of also nice features about that product. The tool was built by Gerlof Langeveld, who's working at AT Computing, and the ftp.nluug server is one of his machines where a new version is being tested and statistics are gathered, and sometimes based on what we see on the ftp.nluug.nl, the tool is being modified, and the last modification was that we had such high counters that some columns were too small, and the tool was being modified for that. Another tool what's being used is MRTG. MRTG we use for monitoring the interfaces, uptime and some disk space. Yeah, like everybody who's using MRTG, it's very useful to do some historical statistics. And besides MRTG, Munin is installed on the system. It's digging more deeply into the systems. On the left topmost graph you see the disk throughput. At the moment our average throughput is about 14 megabytes per second, with some peaks of 430 megabytes per second, so it's busy. We see a lot of I/O, and CPU usage. It's at the moment, on average, we have 50% idle time and 25% I/O weight, so that's okay for me. I have more CPU cycles to spend, and if the I/O weight stays low, then we can serve more data. I'm also using Nagios, that's running on a server I have at home, and it's monitoring the health of the RAID controller. It's also looking for processes that are running a long time. And I wrote that special check for hanging rsync sessions, rsync from or remirror some very slow sites, and occasionally the rsync process was being started, so the content wasn't refreshed on the server. So I wrote a Nagios check for rsync processes running longer than 8 hours, and if that happens, I got an email because the processes started up again, and then the mirror is being continued. Also digging into the Apache status. So I have some trending on a long period of the server. In this case, I use the PMP for Nagios for showing those statistics. The decisions for building the new server, around 2 years ago, we need to expand the disk space. We bought a couple of drives. The drives weren't capable of, there were some issues of replacing the current drives in that SCSI extender. And finally, we had to rebuild a complete new server which can hold all the disks. The design decision, okay, we had to have a lot of I/O. Disk as I/O should be as fast as possible. A lot of traffic, so we decided to bond 4 gigabit Ethernet interfaces to serve the files. It's a public mirror server, so downtime isn't that critical. If this server is down, there are a lot of servers that also can handle the files we serve. So it wasn't that important that we have 2 machines where each machine can handle the load of the other machine. It should be cost effective because NLUUG doesn't have a shitload of money. So the new server, including the whole disk, was about 5K to build. For the RAID setup, it was built in November 2012. At that moment, this LSI controller was the most effective controller at that moment. It has 1 gig of cache memory and can hold a lot of drives. The drives were just SATA disks. At that time I decided, okay, the Hitachi, it has 5 years guarantee, so that should be fine for a long time, because I don't want to replace every 2 months drives. Because you have to step in the car, drive to the data center, replace some drives, so this decision was made to buy high quality drives. The RAID setup is 12 disk in RAID 5 with a 256K stripe size, because a lot of small files are hanging around, and a larger stripe size. Maybe it is increasing the speed, but at that time I implemented this. So what has changed? From 2 servers, where every server was connected with a 1 gig interface to the internet, and at that time every interface has 1 separate IP address. And it's IPv4 and IPv6, so load balancing wasn't that great. It was DNS round robin, and based on your DNS entry, you go to the FTP1 or to the FTP2 server. And this is the current situation. We only have 1 server. It's called FTP2. That's because of the DNS entry we have. We have 4 gig interfaces connecting directly to a switch on ServNet. The interfaces are in the bonding, so the maximum speed per is 1 gigabit for 1 session. And if you set up multiple sessions, the chance that you get another Ethernet card is increasing. So if you set up multiple sessions, you can go beyond the 1 gig. Okay, we have set up that environment, and we encountered a problem in the first place. I didn't know the configuration of the switches at ServNet, so I created an inbound and outbound balancing bonded interface. But that didn't work out as we thought. The maximum speed of all interfaces together didn't exceed a gigabit, so then you're starting to question, okay, what am I doing wrong? And the bonding isn't that great when you are directly connected to Cisco switches. So together with ServNet engineer, we are moved instead of an inbound-outbound balancing to 802.3AD, which is a better way to bonding mechanism when you are connected to Cisco switches. Throughput was raised a little bit, but not that much. So I did a lot of changes in the bonding interfaces. Try to get more bandwidth. Then you are going to think, okay, bonding is fine. Maybe it's the firmware version of the Ethernet card. So I upgraded, downgraded, tweaked something, but it also didn't work out. Then you start tuning buffers on your Ethernet cards. Yeah, it didn't went well. And at that time, after a long period, on a Sunday morning I was in a Skype session with a circuit engineer and suddenly say, crap. This was a special occasion. We are connected to a large Cisco switch, and that switch was modular. And the modularity was we have 8 front and gigabit ports, but on the back end it was only a 1 gig port. So you can tune a lot on your system, but you never get above the 1 gig. And I asked him, okay, on which port was that server? Okay, it was on 3, 4, 5 and 6. It was just a single card. And that was around 18 July 2013. And after a long period, because it was summer vacation, the engineer was on vacation, I was on vacation. On 4 August, the ports were shuffled. So we had spread over 4 modules, and then suddenly peaks of 2.4 gigs were seen on the system. So it wasn't clear in the beginning where the fault was, and only when you look at the front end, your server, your software, and then on network layer, and when you have a smart enough engineer who knows about the history of the switches, then it was clear that we are on the wrong switch ports. Okay, this is the process of tuning. In the beginning you tweak something, you didn't write it down, and then the speed is increasing or decreasing and you don't know what you have done. So the most important thing is write things down, what you did, when you did it, at what time, look at your statistics, and then you get a feeling about what's going on the system. Buffers were too small, timeouts were too long on the system. And you read around on the internet, there are a lot of articles which describe performance tuning in a particular way. But this is a public mirror server, we do a lot of reads, less writes, and everybody in the world can connect to the server. And we cannot predict of what load we're going to get on a particular day. And when you change parameters, it's not directly seen on the system if that's helping. Sometimes I change parameters on a Sunday, then suddenly it peaks to 700 megabit. And on the Monday, the performance is less than 300 megabits. So yeah, then they are guessing, okay, what have I done? Is it only that we have a small amount of hits coming in, so that the throughput is big, and on the next day, everybody is waking up, start mirroring, so we have a lot of sessions, and then the throughput is low. So sometimes very difficult to predict the effect of the tuning parameters. In this graph you can see that we can get throughputs. This is a snapshot, I think in August 2013. On 5-minute average we had a throughput of 2.3 gig, and at that moment that was the biggest peak I've ever seen on that system. Probably was because OpenSUSE 13.1 came out on that day, and everybody was mirroring from our server. What I tweaked a lot is the buffers on networking. On the network card you can set the ring buffers on incoming and outgoing buffers. On the default Ethernet card the buffers are set to about 512 bytes, and I raised it incoming and outgoing to about 4K. And the speed was increasing. Then I found out about another parameter, the TXQ lane. You set it with ifconfig, and that was the parameter that raised the throughput. I've tried different versions of TCP congestion control, and at the moment I'm running the Reno congestion control. And on the Ethernet card I've also enabled the offloading of GSO and GRO. On file system level, I created file system of 3 terabyte. My idea was, okay, we have a lot of small files, so 3 terabyte is a lot, and when you put a lot of small files on it, in case of a reboot of the server and some file system inconsistency, then a 3 terabyte volume is probably faster than one big file systems. And yeah, that's only for system maintenance. The scheduler of the disk, the standard is CFQ for Linux. I've tried several ones, but the no op or no scaling at all is in this specific instance is the best, because the RAID controller is intelligent enough to handle the I/O. The file systems are ext4, but I have to make the decision at the moment. Maybe I should try ButterFS or XFS.
ZFS.
Yeah, could also be a nice suggestion, but
No, you just do ZFS on Linux. I've done production now on a system that's twice this size, and it does 3 times the throughput that you would say this does here.
yeah, but last week I found out that the file system isn't the issue. I gave this presentation a week ago to my colleagues at work, and they say, okay, you should try this and you should try that, and okay, maybe that's the solution for it. But then I logged into the system, and on particularly in time there was a lot of rsyncs who are pulling for us, and at that time the bandwidth was about 1.8 gigabit. So I logged into a machine, started a session about 800 megabit, and it went fine. So the file systems aren't the issue at the moment.
It should be.
Yeah, but I probably cannot. The layout of the file systems at this moment is sufficient enough to handle 4 times 1 gig. On OS level, I did some tweaking. IRQ balance, I set that to 1 shot because I don't want the system to change IRQs all the time. I don't know why I did it. It was just a guess, and it worked out fine. Then I found out that there was CPU throttling. That was also interfering with the process, so I also disabled that. I had in the beginning some issues with memory. All my memories was being used, so I set the VM min 3 kilobytes, and after setting that parameter, the system was more stable than before. Raised the U limit as usual, and what's hitting me especially for the RPM-based distribution, is the YUM plugin fastest mirror. That's a module that's connecting to a server on the HTTP port and check how fast the server is reacting. I tried from different internet locations, okay, what is then the speed to ftp.nluug.nl? The ftp.nluug.nl is, from that specific machine, is 1.533 milliseconds, which is very fast. But there are some other servers that were faster than NLUUG. But when you do some mathematics, the difference between the fastest and the NLUUG is only 0.16 milliseconds. So I have to tweak the machine that it's a fraction of a millisecond faster than other machines, and then we are getting more hits. I don't think that's possible because I don't know the internet connections to that machine. So from one provider, the ftp.nluug could be faster than other providers.
It should be the fastest in the Netherlands. And it can be the fastest in the Netherlands.
Okay.
You have to talk after this meeting.
Do you know if the fastest mirror plugin is measuring just the ping latency, or is it measuring download speed?
No,
as well?
it's opening a session on port 80, probably not closing it. It's, I think, only the SYNAC to port 80 on the machine. I've did something in the it's a Python script that's doing that, and it's opening a port 80, measures the time that's needed to open that port.
So that will mean that if you had a shitty machine that is very slow but has a very fast connection time, the YUM will go for that.
Yeah. So that's the problem. It's only measuring the first connection and not the throughput of the whole machine.
If you want the traffic, you use a load balancer that gives you a really fast response on your port 80, and then when you really get to the data, you can be milliseconds slower, because that's not the real issue that's being measured. I know what hardware is behind the mirror called whiteaxis.nl, because I've been supporting it for a year, so it might be interesting.
Okay.
And that mirror.prolocation.net is just using partly the same network infrastructure as the ftp.nluug.nl.
Yeah. So I have to tweak it so that port 80 is slightly faster. But what you can do is put a preferred server in your fastestmirror.com. So if you spread it out, then we'll probably be the first one if we have the preferred server in. What we use on the application level. We use plain rsync, just a standard configuration. The only thing is that we're running it 4 times. Running of the 4 times, that's being the legacy implementation, because before that one server we had 4 Ethernet cards, with every card was running 1 instance. So at the moment it's still running like that, so we have 1 rsync on the first IPv4 port, an rsync for the second IPv4, and also for IPv6. Need to change that in the future, but didn't do that. And the same is for VSFTPD. On Apache, I already migrated, instead of running 4 instances, 1 instance per IP port, to only 1 instance, and it's serving all the IPs. These are some settings. I also tweaked a lot of it. What I now see is that we have less sessions, but the throughput is higher. And before I tweaked it, sometimes we had 60K connections at some time, and now it's less, but throughput has been raised. For the future, the machine is running only 16 gig of memory, so it's not that much for a server. We want to upgrade to 32 gig, and that will be done in the near future, because last Tuesday I was at a client. We talked about ftp.nluug.nl. He asked about specs of the machine and say, oh, I'm scrapping one machine. I've got some memory for you. Do you want to have it? So thanks for that client. We are upgrading to 32 gig of memory. So some more file caching, which can increase bandwidth.
How much rack space do you have available?
We have a whole rack.
Half rack.
Half a rack.
Half rack. So it can house a complete 7U high chassis with 10 machines that each have 32 gigs of RAM.
Yeah, could be.
Okay, then.
But this machine can handle the load, so I don't need.
So does NLUUG pay for power expenses?
No, the housing, including the internet connection, is being donated by ServNet.
So I think the NLUUG mirror should be the fastest in Europe. We have to talk after this meeting.
Okay.
I want to make sure that that happens.
We will definitely do, because at the moment I'm the only guy who are doing performance tuning, and my knowledge is limited, because this is a very special occasion. We have a lot of files, we have a lot of bandwidth, but
so who chooses what projects are being mirrored and which are not?
a couple of guys sitting behind you.
We do.
Okay.
Yeah.
So how much capacity would we have to add to do everything anyone requests?
I don't know, because at the moment we can serve new requests,
Because it's
and we do that.
17 terabytes now, right?
Yeah.
So is there enough stuff in the world to house 3 times that amount?
Well, there's always enough crap.
Yeah.
Well, I mean,
But
useful to crap.
I wouldn't mind more disk space.
Yeah.
I wouldn't mind more disk space, but
No.
So let's talk about that.
Okay.
Well,
So
more disk space is not a problem if we got a use for it.
yeah.
So
And-
If
this-
we have a use case, then the NLUUG is more than happy to get more disk space in machines.
Yeah. So I have more slots available, and nowadays the 4 terabyte disks are not that expensive. So about 1,500 euros will extend the system with maximum